Question 3. Scientists measure a bacteria population and find that it is 10,000. All right, let's write this down. Let's highlight this. Let's write it down. Here in blue, we got 10,000. We're starting with 10,000. When you measure it, that's where you start. That's the beginning. Let's write this down here. 10,000. So, the scientists measured the bacteria. They found there's 10,000. 5 days later, they find the population has doubled. All right. And they say, which function F could describe the bacteria population D days after scientists first measured it? Assume it is growing exponentially. So if it's growing exponentially, we're going to have that same growth rate. We just keep multiplying times 2. It's getting doubled. See, it's underlined in pink there, doubled. Well, there's our growth rate. Because this is an exponential function, we're just going to keep multiplying times 2 over and over and over again. Every 5 days, we multiply times 2. So, once again, here's where we started. Here's our growth rate, what we're multiplying times, and we're going to have an exponential up here. Our variable will be in the exponent position. And they say, what are they saying? Which function F could describe the bacteria population in D days? So D for days. So I guess we're going to be thinking about each day that goes by. Now we know that it takes 5 days for this thing to double. Every 5 days it is doubling. So how many days? If 1 day goes by, how much did it grow? Well, let's grab another color here. Maybe, how about green? Oh, orange looks good. Orange. D days. D for days. I'm going to highlight that right here. D days. Well, every 5 days this thing's going to double. And I know that 1 day is 1 out of 5. So my exponent is going to be D out of 5 days. And they made it just a little bit, took it to another level for us, just a tiny little bit. Remember, we need to remember our exponent rules. If we were to write this, let's forget about the 10,000 for a second. Just think about our growth factor. We keep multiplying times 2. And 2 to the power of D over 5. Let's remember where these two things go when we rewrite this as a radical. So we're going to have 2 in pink. We're doubling every 5 days. And now my the 5 in the denominator, that's the root. We're taking the 5th root of this thing. Only 1 of the 5 days has gone by. So we got 1 over 5 here. And to the power of D for days. That we could put it under here. Or we could also write it out here. It means the same thing, basically. If we're raising it to the power of the numerator. So here's what we need to focus on. The numerator's here. The denominator is what goes on the root, right? The numerator makes it bigger up on top. When we raise something to the power of something, it's growing larger usually, as long as it's a positive integer. But if it's in the denominator, it's making it smaller. The larger the denominator, the smaller this thing gets. And that's where we take our root right there. It goes down there. And it looks like that answer is right there. So we know that 1 out of 5 days has passed. We've got 2 to the power of 1/5 for each day that goes by. And in green, we will circle our correct answer, which is right here. And here, if you completely understand and make total sense to you, you could stop the video now. But I kind of want to talk to you a little bit more about 3A here. Let's take a moment. Just in case you're feeling lost and confused, let's take a look at this other example up here, 3A, that I came up with. It's a little simpler than this. And so I feel like you'll be able to grasp it a little more easily, possibly. All right, 3A. A popular Algebra 2 class begins the year with 20 students. And the class is so popular that each month the number of students enrolled in the class triples. Write a function that describes the relationship between the time the class started and the number of students enrolled in the class as a function of weeks. So let's get rid of this thing right here. So every time we write one of these exponential equations, here's where we start. We got to start at the beginning. We started right here with 20 students at the beginning. So that's where this is going to go right into our formula right there at the beginning. It makes total sense to start at the beginning. Now they're telling me that it's tripling, right? It triples. So here's our growth factor. Here's the rate of change. We just keep multiplying times 3 every month. They tell me it takes a month and the number of students will triple, multiply it times 3. So if you were going to write this equation for months, you could put, maybe we change W to M for months. What other colors I got? We'd say M for months. We'd raise it to the power of months. And then every month that goes by, we multiply times 3. But they want us to write this for weeks. Okay, so we got to think about how many weeks are in a month. Right, we're not writing for this for months. We're going to write it for weeks. So we write our formula for weeks. We start with the 20 where we started from. We've got this growth rate of 3. It's tripling. We multiply times 3. But instead of a whole month going by and this thing tripling, only 1 out of 4 weeks has passed. So 1 out of 4 weeks has gone by. And what we would do is we'd just put our W up there. So each week out of 4, we're going to multiply 20 times 3 to the power of 1/4 each week that goes by. So guess what happens after 4 weeks goes by and we hit that full month? You know what you're going to get? You're going to get 4 over 4. And that equals 1. And 3 to the power of 1 is 3 times 20. And that is how it triples after 4 weeks or 1 month. It works perfectly, I promise you. If you try some different numbers, time periods. If you were going to, let's say a year went by, right? And we were doing this for months, because they said it triples in a month. If we had M in here for months, he'd put 12 up here for the year, because 12 months went by. But we're looking for weeks, and each week is only a quarter of that month that it takes to triple this thing. So when we rewrite this, remembering our exponent rules that we studied in the last unit, we've got this students, the number of students in an algebra class as a function of weeks equals 20. The 20 original students that we started with. We got this tripling effect. We're going to be multiplying times 3 every month. And instead of writing it as 3 to the power of W over 4, we're going to rewrite that with a radical. This is the 4th root. Let's scooch this over a little bit. What are you doing? I'll have to use an eraser. Here's the 3. We're just trying to convert that to 3 to the power of W over 4 to a radical. Right, let's put the hat on there. Bing, there's the radical. Now my denominator is 4. That goes right here on the root. So 4. Or look, we had it in green. Maybe we keep it green. The 4th root. We'll make the little hat green too. The 4th root, and the D stays up on top. That's the numerator. Or not, I'm saying D for days. No, it's W for weeks, right? We'll leave the W up here. And here's how we can express this thing. And that's kind of the way that they wrote their answer down here on 3B. So I want to use 3A as a more simpler example to explain this. I hope that helps.